questions for quantities, and today we have to start errors and uncertainty. Okay, actually they are the both things. Error means the same thing, but qualitative, and uncertainty is the same thing but in quantitative matter. In when we are studying errors, we will be discussing that how and why there can be a difference between the actual value and the measured value. But when we will be discussing uncertainty, we will be finding the numeric value of that doubt that is produced because of. So let's start with error. Errors are produced because of errors are differences or doubts. For example, if there is a scale, you have a scale and you're using it to measure something. Let's say this is an object you're trying to measure. So what happens is, for example, this is 3 centimeter, 1, 2, 3, 4, 5, 1, 2, 3, 4, and this is 4 centimeter, 1, 2. This is 5 centimeter. Now, if somebody asks you, what is this reading right now? So this scale has, this ruler can only offer you 3.2 and 3.3. So you have to make a decision. Do you think it is 3.3 or do you think it is 3.2? So you cannot make it 3.28 if you think that it is very close to 3.3, so it is 2. No, you have to make a decision whether it is 3.2 or 3.3. Do you think this will produce some doubt in the measurement? Similarly, this one is 4.5, 6, 7, and 8. This is 4.7, and this is 4.8. So make a decision whether it is 4.8 or 4.7. Now, let's make this confusion a bit bigger. Instead of measuring something that can be very close to the ruler, what if you are measuring something which is like this? No, the will be, in this case, when you will be measuring this thing, this is the end and this is the reading. Let me clear these reading. Now, the problem will be that when you will be looking at the reading, the edge is here and the reading is here. There's a difference. So with the placement of your eye, for example, if your eye is here, so you might look at this reading. And if your eye is slightly here, you might look at this reading. Right now, you think that, no, I will keep my eye over there. That seems very easy, but you can never be 100% sure whether your line of sight is actually perpendicular or not. So, and you can increase the problem if you're measuring something that looks like this. Just 1 second, let me go there. And what if something looks like this? Now, when you will be measuring it, the problem will be the end is here and the reading is there. This is the point, and this is reading, and they are not together. So this will produce a doubt in the measurement. And these kind of doubts are called errors. Okay, that is one example. Another example is, for example, there is an edge like this and this. Okay. These are two walls, and somebody asks you to measure this length, and you use a ruler for that. So what you do is you place your ruler like this. Just let me make the diagram correct. So what you do is you put your ruler in the edge like this, and you're looking for this length. How big is this length? And the problem is that your ruler starts from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is some remaining ruler. We don't, we are not uh, considering it. Now, who sees the problem here? This is the length, and it seems like it is 9 centimeters. But you are ignoring one thing. This is the problem. This problem is called zero error. So this will produce a kind of difference in the measurement, because your ruler is not starting from zero. The edge of the ruler is not starting from zero. So this measurement is not actually, if somebody thinks that it is equal to 9.0 centimeters, you are wrong. It cannot be 9 centimeters. It is definitely a bit more than that. How much more? This much more. So these kind of differences, because of the instrument and sometimes because of the human limitations over here, this is a human limitation. We don't know when and where the eye is perpendicular to the scale. So we are producing a parallax error, and we are producing a zero error. Some errors are because of system or instruments. Sometimes errors are there because of human limitations. So let's discuss errors today and how do they affect different kind of measurements. Errors are classified in physics as systematic errors, and the others are random errors. Now, what are systematic errors? Errors because of movement are called systematic errors. Errors because of instruments are called systematic errors. These errors have fixed and predictable values. These errors can be fixed by simple arithmetical processes. Like we can simply add or subtract. If for example, we were measuring this corner, and the problem was that in the corner there was some extra ruler that was not included in the reading. What we can do is we can just record this reading 9.0 centimeter, which is coming on this ruler. Then we go and we can measure this extra error. We can measure this error, and then we can add that error over here to find exact length. So these kind of, for example, if you use this ruler to find 10 or 20 different measurements, and at the end you realize, oh, there was some zero error over there in every value that you have measured. So you should not go back and measure every length again. What you can do is you can see all that data, you can find out the error, and then you can fix that error by simply adding or subtracting from the value that you have measured. So systematic errors can be fixed by simple adding and subtracting. Now, systematic errors affect accuracy of measurement. Like it affects your accuracy of measurements. And accuracy is not a general term over here. Accuracy has a specific definition in physics. What is meant by accuracy? Accuracy is defined as closeness of measured value to true value is called accuracy. And now I have used another term, which is true value. What is true value? True value is a value that we find using careful theoretical calculations, or a value that is established after many experiments over a long period of time. Try to understand these two kinds of true values. One is a value that we can calculate using theoretical uh, calculation, theoretical formulas and theoretical laws and everything. There is a mathematical way of finding the true value. And another thing is that we keep repeating an experiment for 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 decades or sometimes for centuries, and then we find a value, and then we can consider it as a true value. For example, if somebody asks you what is the true value of gravitational acceleration near the surface of Earth, you can simply say it is 9.81 meter per second square. So what is that? That is a true value because it has been measured again and again and again and again by different scientists over a very long period of time, and they all found the value to be 9.81 meter per second square. So that is why we can consider it as a true value. Similarly, mass of electron or charge on electron, elementary charge, Planck's constant, these are the values that scientists found over and over again, and their values can be considered as true value. And then if you perform an experiment, what value you get for the same thing, you can compare it with the true value and see whether you are accurate or you're not accurate. Now, what is the other kind of errors? Let me put a separate over this so things don't get mixed up. Okay, now random errors. Errors caused because of human limitations are called random errors. For example, human reflex action delay. Uh, Errors caused by human limitations are called random errors. These errors do not have fixed value or fixed sign. They can be positive or negative. Be positive or negative and more or less. Their value is predictable. We cannot predict how much random error will be there in any specific measurement. So random errors are unpredictable. So we cannot fix them using simple arithmetical procedures. So to fix random errors, we find many values and then calculate their average or plot graph and sketch best fit line or curve. So these are the techniques that we can use to fix random errors, because they don't have any fixed value. They can be more or less, they can be positive or negative. So what we do is we repeat so many times, like we repeat a simple measurement 6 times, 10 times, and then we find average. And we assume, because we have repeated so many times, so we have to make some big positive errors, some big negative errors, some small positive errors, some small negative errors. And when we will be finding average, they all will self fix one another. They will self compensate one another. So this is an assumption, but it works. It works because we are making random errors, and actually random errors can be positive, negative, more or less. So the only way to fix them is find average. Now, random errors affect precision. What is precision? Now, in general, precision and accuracy can go for one another in general understanding, but in physics, precision is something else and accuracy is something else. Now, what is precision? Okay, precision. Closeness among measured values is called precision. So it is not closeness to any fixed true value, but it is closeness among all measured value. For example, if you have measured a quantity 10 times, and there are very small differences in every measurement, it means you are very precise. And if there are large differences between the measurements of the same quantity at the same time, it means you are less precise. So precision means closeness among measured value. For example, if two people measure value of G, person one, G in meter per second square. So he measures it 10.8, 10.7, 10.8, 10.6. Another person, person two, measures the value of G and finds it 8.8, 9.8, 9.1, and 10.6. Hello, can you hear me? Can anybody
Yes, sir.
confirm whether you
Yes,
get?
sir. Yes,
Oh,
sir.
thank you very much. I think I lost the connection for some time. Okay, I need your help over here. Somebody, actually, all of you should do it. Let's see.
Okay.
There are two people who measured the value of G, and I hope you can see the values. Person one
Yes, sir.
measured 10.8, 10.7, 10.8, 10.6. Can you find the average value of for this person?
Yes, sir.
Now, find the average value. One of you can tell me the average value, and one more person can confirm whether it is right or wrong. To find average of four values, you simply add them and then divide them with 4. And the easier way is just 10 is common in everyone. 8 and 7 is 1.5 plus 8 is 2.3. 2.9 divided by 4 is
10.7.
7.15. 10.7. 725, I think.
Yes, sir.
Okay. So 10.7 meter per second square. And the other person measures it. He should get around 9 point.
So 9.9.
9 point
9.
exact.
Yes, sir.
Okay, 9.9 meter per second square. Now look at the difference between the smallest value and the largest value for the first person. The largest value is 10.8 and the smallest value is 10.6, and the difference will be 0.2. What will be the largest value and smallest value difference between largest and smallest value for the second person? Three point one. Can you people confirm? I do not have a calculator right now. 11.9 minus 8.8. Yes, it is 3.1. Now listen. Pay attention over here. Look at the first person. Is he accurate? He's getting gravitational acceleration on Earth 10.7. Do you know what is the true value of gravitational acceleration? 9.8. So this person is about 1 meter per second square off. That is around 10% off. Okay. So this person one, is not accurate because his average value is not close to the true value. But look at the values he's getting. Are these values close to one another?
Yes, sir.
So we will say that this person is not accurate, but precise. I hope with this example, you should understand what accuracy is and what precision is. Precision means how close your measured values are from one another. And accuracy means how close your measured value, average measured value, is from the true value. Look at the second person. We know he's getting an average value 9.9, and actually it is 9.8 meter per second square. So do you think he's accurate?
Yes, sir.
This person is more accurate, but less precise, because his measured values are not very close to one another. Sometimes he makes a negative error of 1, sometimes he's making a positive error of 2. So he's everywhere actually. So this kind of error is producing or affecting precision. Now I'm about to ask the most difficult part of the whole thing. So stay with me on this one. What kind of errors were made by person 1, and what kind of errors were made by person 2? Remember, precision. Precision is affected by random errors. Closeness among measured values is called precision. Random errors affect precision, but not accuracy. And systematic errors affect accuracy of the measurement, but not precision. So if you are making a systematic error, you have one malfunctioning measuring device, then what will happen is every measurement that you will make will be equally off, and you will be having systematic error. But because you're using the same modified instrument, you will be having same error, and every time you calculate the final answer, you should have the same error. So your difference will be equal, and all your values will be incorrect but very close to one another. That means systematic error will not be affecting precision of the measurement. So what kind of errors were made by person 1? Was he making too much systematic errors or too much random errors?
Random errors.
And how can you say that?
Because it was not accurate, but it was precise.
And precision affects accuracy, or sorry, random errors affect precision or accuracy?
So they affect precision.
So first person is precise. Precision is not affected. So this person is making systematic errors. So you can simply say high systematic errors and low random errors. So this person is making systematic errors, and the second person is making more random errors and less systematic errors. Because if there would be systematic errors, all of this person's answers would be in the same way, like they all should be positive or they all should be negative. It cannot be like some are more, some are less. It means some something is wrong with the way this person is measuring things. So this is because of the human errors, which are unpredictable. They can be more or less, positive or negative. That's why this person is making random errors, person 2. So this is how systematic errors and random errors are different from one another. And this is an introduction of errors, and you need to understand 4 terms over here. Let's go about them once again. Systematic errors, random errors. What are systematic errors? Errors because of the modified instruments or incorrect instruments. Random errors, errors because of the human limitations. Systematic errors, they have fixed values. Random errors, they have unpredictable, unfixed values. Systematic errors can easily be fixed by plus or minus or multiply, divide. And for random errors, you have to take averages, plot graphs, make best fit lines, or draw best fit curves, and then you can fix random errors. Random errors affect precision. Systematic errors affect accuracy. Accuracy means closeness of the measured value to the true value. Precision means closeness of measured value to other measured values. And examiner gives you uh, like it is a very straightforward theory question. What is precision? What is accuracy? What is systematic error? What is random error? Very straightforward question seen too many times in exams in previous years. So I think today we will be ending here, and tomorrow we will give this thing a recap, and then we will start doing uncertainties. Okay.
Okay, sir.
See you people. See you people tomorrow. Thank you very much.